Hello everyone, and welcome to the video lecture series of learning theory of automata and formal languages. My name is Binayak Parashar. I am working as an assistant professor in the Department of Computer Science and Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So, this is the video lecture series which will be starting with the subject known as theory of automata and formal languages, as you can see here. So, we will be continuing with almost more than 40 lecture series of which will be covering almost all the topics related to your syllabus. And if you want to go with this particular subject, we should understand why we are learning this subject. This is very important thing, okay, because we should also understand what are the consequences of learning this subject, where this subject will be helpful for you all, and where it can be applied in future. Okay. So, basically what is our agenda is that we will be trying to learn first of all what is the subject definition is all about, what are the contents. Okay. So, if we are trying to learn any new subjects, we generally focus on three important things. First thing is that what is the definition of that particular subject, why we are studying that subject, and where it is being applied. If you are well known with all these three topics, then I am pretty much sure that you will be able to succeed with that subject. Now, second thing is that what is my way of working or my way of teaching to you all is that we will be focusing first of all unit wise. See, in this particular subject you need to understand that what is the definition first, and then you will be able to relate with the application, or you will be able to relate with the real time applications. Okay. So, we will first go with the topic wise, and then we will discuss what are its applications, because in the first moment if we start off with the applications, it will be little bit tough for you to relate. Yes, you will be able to understand what are the applications, but you will not be able to relate properly. Okay. So, and one more thing is that regarding this particular subject is that in the first few 4-5 lectures you will not be able to understand, or you will not be able to relate properly. You will be able to understand the contents, but you will not be able to relate. Once the topics will be covered one by one, you will come across with the real time applications, and then you will be able to relate the topics. So, in the today's video lecture, we will be discussing about introduction to the theory of computation, automata, alphabet symbols, string, and formal languages. So, these are the basic topics that we are going to start off with today's agenda. Okay. Now, let us go with the first slide, that is the introduction part. But before going into the slide, we need to understand the definition of this particular subject. The subject name is Theory of Automata and its Formal Languages. Now, skip the other half, formal languages you skip for the first time. Let's stick on to Theory of Automata first of all, because we need to understand the terminology automata first, and then we will come across with the languages part or whatever, so whatever prerequisite terminologies we are having. Okay. Automata is nothing but it's a plural form of automaton. It's nothing but you can say, okay, self will, okay, or we can say it's a self ability to learn or self learning machine. Okay. That means automaton or automata, it's nothing but a machine where we will be having a set of inputs, we will be having a certain area of processing, and then we will be producing the output to the end user. This is the general concept of every machine. But what is the theory of automata means? Theory of automata means that you will be learning every machine theoretical concepts. Okay. Every machine self willingness of the machine, every machine's self acting responsibilities. So, all over the other, if you are learning the basic part of the of entire machines, that is nothing but your theory of automata. Okay. So, first of all we will be learning the terminology automaton, then we will be coming across with the concepts of automata. Okay. So, first point is says that automata theory is an exciting and a theoretical branch of computer science. Okay. Theoretical branch of computer science. I want to pause for a minute and I will let you know that this theoretical branch of computer science will help you where. First of all, you will be coming across after passing your or by the end of your BTech, you will be going for different type of competitive exams like GATE examination, like UGC NET also you will be giving. In those examinations, this particular subject carries a lot of marks. Okay. So, you need to concentrate from that point of view also. Almost out of 100 marks or out of 70 marks, 10 marks comes from this particular subject only. Okay. So, you need to understand every basic terminologies, you need to be clear with the every basic terminologies. Okay. So, right now we will be learning this particular subject as a media of the theoretical concept of computer science, how a computer, how a general machine generally works. Okay. If we have a particular base model of every machines, then it will be easy for us to analyze how the machine will work. That means, if we are having a set of inputs, we are having a set of outputs, and some set of processing will be done based on which the output will be produced to you. So, that is the overall definition of, we say, automaton, okay, or the plural form is automata. Okay. Now, come to the next point. Next point says that automaton is an abstract computing device. Abstract, it is not real. We are just trying to abstract few key features from every machines, and we need to understand as an end user, not a developer. Okay. Suppose I am a developer, I have developed the entire machine, but if we are producing or if we are submitting that particular machine to the end user responsibility is just to work with the machine, not to understand the inside part. So, we can say that this automaton or this automata is nothing but an abstract computer device, okay, an abstract machine. Okay. This is one particular point that you should keep in mind, abstract. Okay. Then next point you have come across is a theoretical branch. Okay. Now, next point you look into this is simply stated, automata theory deals with the logic of computation with respect to simple machines, referred to as automata. We will just try to understand this simple thing, inputs, processing, outputs, how to work with this particular concept and to produce a base model of entire all the machines that we are going to learn in the chapter. Okay. The next, through automata, computer scientists can understand how machines compute functions and solve problems. Suppose you have got a base model, if you have got a base algorithm of all the machines, and that particular base model explains how the inputs have been has been received, what is the processing being done, and how the output has been produced to the end user. So, if you can understand this simple thing, then all the machines will have a prior understanding. Clear? Now, let us go with the next slide. Now, next slide we will come across this important person name, which you should always understand, or you should always well aware of it. His name is Sir Alan Turing, and he lives for the year 1912 to 1954, and during this era he has developed the most powerful universal machine existing till now. Why? Because based on that model, all the different machines has been constructed. Okay. Now, Alan Turing sir has developed a particular machine named as Turing machine. Okay. Now, this Turing machine is the model that generally describes the entire functionality of all the machines, that already I have told you, set of inputs, set of outputs, and the processing. Okay. And how did Alan Turing has developed this, that you will be coming across in unit number 5. Till that you need to be patient. You need to understand what are the different basic models underlying. Okay. Now, Alan Turing has been referred as the father of modern computer. Then he was an English mathematician. Okay. Then Turing machine that I have already mentioned to you, Turing machine. Okay. It's essentially an abstract model of modern day computer. What it does, it's execution and storage part. So, if you look into this particular 2 points, execution and storage part, that means what I have told you, that set of inputs producing some output and some processing. This processing is the main part which generally analyze every different types of machines. I think you are clear with this. So, for the time being, you just keep in mind that Alan Turing sir, in the year for the duration 1912 to 1954, he has designed this particular concept of known as Turing machine, and also been named as the father of modern computer. Okay. Now, we will be learning this particular part in the upcoming lectures, but let's go forward and let's go with the topic. Let's go with the terminologies first. Okay. So, our first terminology is your automata. Okay. Automata, already I have told you, automata is nothing but what? It's a abstract model of machines. It's a abstract model of machines. Now, you will be thinking that what is this abstract model of machines? Okay. I am having some set of inputs. Okay. I am having some set of outputs. how I got these outputs from inputs to outputs, definitely some set of processing is being done, some set of processing is being done. So, is this particular concept, okay, together put forward into a self acting prophecy, and that is being done by the terminology that is known as your automata. Okay. Now, what are the terminologies which we need to understand, that we should keep in mind? First of all, we need to understand few of the terminologies like states and configurations. Okay. Then we need to understand some set of, as a result, once the computation reaches an accepting configuration. Okay. I am just trying to carry forward some of the important terminologies that we will analyze the things. Okay. And then we will try to find out the objective of the machine. Okay. Objective of the machine is that to analyze the dynamic behavior of discrete systems. It is not the static behavior, it is a dynamic behavior of different systems, and put forward and based and put forward together into a base model. That is the main objective of the automata theory, correct. But in order to design that machine, we need to understand the few terminologies like states and its configurations, then accepting configuration. Okay. Then one more terminology will be coming across, that is your transition. Okay. So, these are the three basic things that you will be coming across with: transition, then states or configuration, then accepting configuration. Okay. We will check one by one, but these are the basic things that you need to understand. Finally, if we look into the characteristics which I have been discussing with you all since the first slide, that is your inputs, outputs and states. These states will define the processing part. These states will define the processing part. Okay. How? Let us discuss in the next slide. Now, this is what a general configuration of an automaton, but we will discuss this part after a little bit later on, because we need to understand first of all what is the meaning of string, okay, what is the meaning of this particular terminology, what is the meaning of this particular terminology, then we will analyze this slide. Okay. Let us skip this slide for a minute and let us go to the some of the basic you can say terminologies, or basic you can say the concepts of automata theory. Okay. The first thing that you need to learn is that I am just putting you the hierarchy what you need to learn. First you need to learn alphabet, okay. Then you need to learn strings, okay. Then you need to learn language. So, these are the three things which like you need to put in your brain, that yes, these will be the three things that you will be using again and again to design a machine. Okay. Now, first let us discuss about alphabet and strings and then language. Now, if you try to relate these three terminologies, these are very similar to what you have learned in English language, right, in any of the language. See, alphabet is nothing but what we know about alphabet. Alphabet is nothing but it is a finite non-empty sets of symbols. Okay. So, you need to understand what is symbol. Symbol can be anything. Okay. Symbol can be what? Symbol can be a binary number, symbol can be an integer, symbol can be an operator. Okay. Symbol can be a bracket, symbol can be a floating point number, it can be anything, right. But if we put together and put in a finite way and say as a non-empty sets, then we can say that is an alphabet. Okay. Now, what are the representation of alphabet? We need to understand here few things also. We need to understand first the terminologies. Second thing what we need to understand, we need to understand their representations as well. Okay. So, if we look into the representations, alphabet is represented by sigma. Okay. Keep in mind, alphabet is represented by sigma. So, if we talk about any symbol, say suppose we talk about binary symbol which is mentioned, these are the examples, then we can write down like this. Okay. Alphabet is equals to 0 and 1. If we talk about any lowercase letters, then we can write down like this. I have already told you non-empty sets. So, set theory will come here. Okay. Next comes digits. If we talk about digits, then it will you need to write like this. If we talk about alphanumeric, it will come across with characters also, it will come across with digits also. So, like this you need to represent an alphabet. I hope it is clear to you all. Let us go with the next slide, and definitely in the next slide you will be coming across what we have learned in the hierarchy. We have learned next one is your strings. So, we will be looking into the next topic, that is your strings. Okay. Now strings are what? Strings are collection of alphabets, right? So we know about this particular thing, like we have learned in different languages also, different books also, right? So string, or we generally say a word, right? It's what? It's a finite collection of symbols selected from the alphabets. Alphabets is denoted by whom? Sigma. Clear? Next, a string can be also empty. Do you agree with this point? You can pause the video and think of it. Yes, string can be empty also. So if the string is an empty, that means nothing is there, null and void, then we have to represent with the help of epsilon. Clear? So that means you have learned two terminologies now, two representations. One is sigma and one is epsilon. Sigma represents alphabet, epsilon represents what? Epsilon represents null string. Clear? Now in this particular strings, we need to come across with different operations that are performed on strings, like prefix calculation, suffix calculation, okay, proper subset, then the length, okay. So these are the few different operations you need to learn. But as of now, as of today's lecture, we will be concentrating only on the length part, okay. Then later on we will be coming across with the different operations. Clear? Now in the length of the string generally determines, suppose I am taking a string, say I am writing over here, say suppose A, B, A, B, A, A. So this is a string, correct? This is a collection of alphabets. Now if I say that what is the length of this particular string, we just simply need to calculate or count the number of alphabets present in the string. That's it. That means 1, 2, 3, 4, 5, 6. So therefore the length will be what? The length will be your 6. So this is as simple as that. Clear? So length is equals to 6. Now how do you represent here? As I have already told you, representations also will go parallelly over here. Okay, we represent like this, modulus sign. Okay, and W is nothing but the particular string definition. So it can be M also, it can be some other characters also, but we generally take string in the form of W only. It's mentioned over here. Okay, that means you came across with one more representation, that is your W. So these representations now you keep in mind. Okay, to find this length, mod of W. So 4 representations you have learned. One is your alphabet, second one is your string, okay, and that string can be what? Empty also. If it is empty, then it is represented by epsilon, and then length of the string, that is modulus of that particular string. Clear? Let's go with the next slide. The next slide says empty string, because like we need to understand this particular concept. Okay, here we need to understand one more operations being performed over the string, that is your power. Okay, so we know alphabet, right? We know alphabet, it's represented like this. If we need to calculate the power of it, we just use, suppose 1, this is to the power 1, okay, to the power 2, to the power 3, okay, then to the power 4. So I hope this is clear to you. Alphabet to the power 1, 2, 3, 4, these are nothing but powers of that particular alphabets. Okay, that means if we take, say suppose if we take over here as A comma B, if I am taking like this, then if I take to the power 2, then it will be like this, A comma B, A comma B. So altogether we can write like this, AA, then BB, AB and BA. I hope it is clear. So these are the 4 terminologies that we can get, AA, BB, AB, BA. These are the strings that we will be getting, right, if we take power to the power. Okay. So that means this particular concept, that is 1, 2, 3, 4, we represent in the form of asterisk. We represent in the form of asterisk. So asterisk generally starts from 0, 1, 2, dot 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 infinity. Clear? So that's what I am writing over here, that it is represented in this form, that power infinity, then it will come across with 0. Whenever the length is 0, we represent what? Length is 0 means what? Null and void. So null and void string is what? Epsilon. And then if it is length is 1, then 0, 1. So 0 and 1 nothing but these are alphabets that I have taken. It can be A, B also, it can be any alphabets that I have already told you. Okay. So here I have taken alphabet as 0 and 1. So that's why it's a combination of. Then length 2 means what? These are length 2. Okay. Length 3 means what? These are length 3. This is what? Length 4. Got it? So it keep on going. It's keep on going depending on the power. So, similarly, I have mentioned the initial alphabets powers also. So, for the time being, you have come across with one more terminology. I am going back, I am writing here only, that is asterisk. So, asterisk determines what? The power. Clear? So, this is what about empty string I have represented over here in a proper way in relation with the power concept, correct. So, that means we have got this asterisk symbol as one more representation, clear. Next comes with the next slide, concatenation of strings. Concatenation means merging of two strings. So, if we are having A, B as one string and C, D as another string, say suppose this is W1, this is W2, okay. Now, if I want to merge concatenate two strings, then it will be A, B, C, D. It is as simple as that. You need to concatenate or need to merge two particular strings, okay. These are the topics which will be coming across soon, okay. Next is reverse of the string. Suppose I am having a string, say suppose A, B, C, D, this is W. Now, reverse of a string, how do we write this reverse particularly? Reverse we write like this, W to the power R, means you need to reverse the particular string, then it will be D, C, B, A. Okay. So, this is what we generally do in string also. So, concatenation of a string, reverse of a string, clear. Next comes powers of an alphabet, which I have discussed right now. Power is nothing but what? Again I am repeating, power of an alphabet is defined by to the power asterisk, okay. And asterisk can be what? Asterisk can be 0, 1, 2 and up till infinity, clear. So, that means we come across the powers of an alphabet in this form, and this is what a general representation. It is not mandatory, you just need to focus on this particular concept. Later on, when we will do certain numericals, you will be like user friendly with these terminologies, clear. So, that means overall what we have understood? We have understood that power of an alphabet is denoted by asterisk, and asterisk generally starts from 0 till infinity. If it is 0, again I am representing, if it is 0, then it will be represented by epsilon, clear. So, now finally, we can go to the last part of today's session, that is your languages. Now, this is one of the most important part of your unit number 1, okay. Till here you have understood, I hope you have understood alphabets, okay, which is denoted by what? Sigma. Then you have understood what? Strings. Generally strings we write with the help of W. Then length of a string, how do we write? Okay. Then you have understood what? You have understood power represented by this one, okay. Then you have come across with the last topic, that is your languages, and languages are the one with the help of which you generally define your emotion, define your statement, define your like mindset, what you are thinking about or you are analyzing that particular concept, okay. So, finally, if we try to relate with your English grammar, then generally what we say that yes, I want to go to that particular place, then your language defines that you are a person who want to go from this place to that place, that is it. So, that means language generally defines the statement, the set of rules that you want to include into that particular concept, and then based on which you are going to design a particular machine. So, that means language is the one with the help of which you are going to design the machine. So, you need to understand first language, then you will be able to design the machine. And where the language generally focuses on? The languages focuses on the strings, okay. L, I am just reading out the sentence which I have mentioned over here. L is said to be the language over A. A is nothing but a alphabet, given set of alphabets if L belongs to this one. That means, if I am having a string, okay, and string is denoted by W, definitely this string comprises what? Alphabets, correct. And then this alphabets to the power this one, that means power this represents the universal set of strings, right. So, that means a language can be defined over this universal set of strings with the help of certain rules, and then you can define the particular or you can design the particular machine, correct. So, for that timing we just put on the definition over here and then just analyze the example of it. What is the first example? Example number 1 says that, okay, example number 1 says that L is a language that comprises of set of even numbers over the alphabet, this one. That means what will be the language over here? L is a language that comprises a set of even numbers over the alphabet 0, 0, 0 and 1. Even numbers means length will be what? Length will be 0, 2, 4, 6, 8 and keep on going, right? That means the language will comprise what? 0 means directly epsilon. This is the first part. That means empty string. 2 means what? 0, 0, 1, 1, 0, 1, yeah, 1, 0. 4 means what? 0, 0, 0, 0, 1, 1, 1, 1 and it will keep on going. So, this is how you took the language in a statement form and put into a representation form, and with the help of this representation you will be able to design a machine. Okay. Now, for your assignment you just pause the video and you can try this particular language. Okay. We will be discussing this particular concept in the upcoming video. So, finally, we deal with the key points of the today's lecture. We discuss about the automata. I am trying to skip this particular concept finite in the next video lecture. Okay. We have discussed about the automata part. Okay. Types of finite automata. We have analyzed this particular two concepts, finite acceptor and finite transducer. See, in the previous slide I have skipped one particular slide, right? Automata and its configuration. This particular slide we will be discussing after understanding lecture number 2 or at the end of the lecture number 2, because you need to understand a design machine of that particular language part. Okay, that is why I have skipped this particular slide. Now, finally, we can see this in case of epsilon and this one we will be learning this particular concept in the upcoming lecture, and this finally this is the model configuration of this. So, overall these key points we need to focus in the upcoming video lecture, where we will be looking into the different types of automata, that is DFA and NFA, and then we will try to design the machines. So, thank you to listen, and let's discuss the next upcoming lecture on the next video. Thank you.